So let's go ahead and solve some applied problems. So first thing we're going to do is find the height of a mountain. So to measure the height of a mountain, a surveyor takes two sightings of the peak at a distance 900 meters apart on a direct line to the mountain. The first observation results in an angle of elevation of 47 degrees, and the second angle results in an angle of elevation of 35 degrees. If the transit was 2 meters high, how tall is the mountain? So this is what we're trying to get. We're trying to get to this point of information. So your first step might be like, oh, what's the angle of this? Which we could totally calculate. Like that's 43 degrees, right? The whole right triangle adds up to 90 degrees. But we don't need to know that. If we can figure out C, because we know this is the only thing we know, we really want to know the angle up here. Well, the first step would be to realize that 47 and this angle over here are complements. So 180 degrees minus 47 degrees is 133 degrees. Now that I know in this triangle it has an angle of 35 degrees and an angle of 135 degrees, I can take 180 degrees minus 133 minus 35 degrees, and I get an angle of 12 degrees. So because I know all my angles, and I know this length down here, I can say that the sine of 12 degrees over 900 is proportionate to the sine of 133 degrees over C. So I get C is 900 sine of 133 degrees over sine of 12, which is about 3,165.86. Now, why did I want to find this? Well, if we think back to the beginning of our trig studies in chapter 5, I know that sine is opposite over hypotenuse. Well, let's look at this triangle, this really big triangle. I know my opposite is this, and I know my hypotenuse is this. So sine of this angle here, which is 35 degrees, is going to be my opposite over my hypotenuse. Sine of 35 degrees is my height over 3,165.86. And I find that my height is 118.6 meters. But wait, remember this key point that the transit was 2 meters tall. So I have to add 2 to that. So our mountain height is 1,818 meters. The last example of this section is about a rescue at sea. So Coast Guard Station Zulu is located 100 miles west of Station X-Ray. A ship at sea, here he is, sends out an SOS call that is received by each station. The call to Station Zulu indicates that the bearing of the ship from Zulu is north 50 degrees east. So that's 50 degrees east of north, right? Meaning this angle would be 40 degrees. The call to Station X-Ray indicates that the bearing of the ship is north 60 degrees west. That means 60 degrees west of north, making this angle 30 degrees because that's a right angle. What I want to know is how far is each station from the ship. So I'm going to go ahead and figure out what this angle is here. I know that A plus B plus C equals 180 degrees. So if I've got 40 degrees plus 30 degrees plus C, I get that C is 110 degrees. Now I really needed to figure out C because the side opposite C is the only length I knew. So I know sine of A over A equals sine of C over C. So that's going to give me sine of 40 over A equals sine of 110 degrees over 100. So I get that A is 100 sine 40 degrees over sine 110, that's about 68.4 miles. So side A is 68.4 miles. Now I can solve side B the same way. Sine of B over B equals sine of C over C. So sine of 30 degrees equals sine over B, which is unknown, is sine of 110 degrees over 100. So I get B is 100 sine 30 degrees over sine of 110 degrees, which is about 53.21 miles. If a helicopter capable of flying 200 miles per hour is dispatched from the nearest station of the ship, this is part B, how long will it take to reach this ship? So first off, you have to decide which station you want to go to. Do you want to go to Zulu or X-ray? Well, you're in distress. So you should probably go to Zulu. It's closer. Remember that distance equals rate times time. So if I'm going 53, and I'm trying to figure out the time, I know that I'm trying to figure out how long it's going to take. So let's solve for time. I get the distance over rate is time. My distance is 53.21. My rate is 200. So I get about 0.27 hours, which is 16 minutes and 53 seconds. So that was our last example of solving examples using the law of sines.